Alright, this is section 4.4. We're going to be talking about the graphs of sine and cosine in this section. So first we're going to talk about the sine function, and we write this as f of x equals sine of x. That's how you'll generally see the basic function. And there's a few things that you need to remember about sine of x. So all of these things that I'm going to tell you are what's really important about the graph of sine. The domain is going to be all real numbers. So that means that I can put any value in for x. Doesn't matter what it is, I can put any value I want in. My range, however, is only going to be from -1 to +1. And you can see from the graph here, it only goes from -1 to +1. Never goes below -1, never goes above -1. Remember, we're talking about just sine of x. We'll talk about how we can make it go above and below by changing this function. But the basic function sine of x does not go below -1 or above +1. The function is continuous. That means that it will keep going, it will keep doing this over and over in both directions forever and ever and ever. It is symmetric about the origin. So it has symmetry around the origin. You can see that the function is bounded because it has a lower bound and an upper bound, so remember we call that bounded. Here's what's really interesting. There are no horizontal asymptotes and there are no vertical asymptotes. So you might think, oh, well, there's probably two horizontal asymptotes, one at -1 and one at +1. That's not true because as x, remember we write asymptotes can be written as x approaches. As x approaches a certain number, your y value doesn't actually approach it because it gets really, really close to -1. It actually gets to -1 here, but then it goes back up, and then it comes back, and then it gets close to -1 again, and then goes back up. So it doesn't actually have an asymptote. It doesn't approach a value. So this kind of goes into our end behavior, and I'm just going to abbreviate that as end behavior. There is no end behavior. And we say that there's no end behavior, but the function oscillates between -1 and 1. So oscillates, think of an oscillating fan. It goes back and forth, back and forth. Our function's going to go up and down, up and down, up and down, forever and ever and ever. Cosine is the other function that we're going to talk about, and this graph is a little bit blurrier, but you can kind of, it's basically the same thing. Again, this is -1 down here, and this is +1 up here. They put the halves in there, and I don't know why, but just make sure you know that this is -1 and this is +1 up here. And this is y equals, or f of x equals, cosine of x. So what you need to know about cosine of x is that the domain is all real numbers, just like sine. The range is -1 to 1, just like sine. Never goes below -1, never goes above 1. This original equation here. This time, it has symmetry, but this time the symmetry is over the y-axis. So you can see that if I took this y-axis here and I folded the graph in half at this y-axis, it would be symmetrical. So it has symmetry over y-axis. Remember, sine had symmetry about the origin. This one has symmetry over the y-axis. Cosine is continuous, just like sine. It's bounded, just like sine. Because it's bounded below and it's bounded above, we say it's bounded. Again, same thing, there's no horizontal asymptotes or vertical asymptotes. And I kind of talked a little bit about why. It's the same reason. And again, same thing as sine. The end behavior is that there is none because it oscillates between -1 and 1. So they have a lot of similarities. Really, the only difference is their symmetry. So I'm going to put two of the graphs next to each other so you can kind of see how they're the same and how they're different. So sine, you can see, is symmetrical about the origin. Cosine, symmetrical about the y-axis. sine also goes through the origin, cosine does not. That's another big difference, and that's going to be important to remember as well. So we can write these functions in a bunch of different ways, but what's going to help us to answer some questions and some properties of the functions is to write it in this way. So you can write f of x equals a times sine bx plus c, that's all in parentheses, plus d. And then you could do the exact same thing for cosine. So f of x is equal to a times cosine of bx plus c plus d. And this form is only true if a, b, c, and d are constants, and neither a nor b is 0. So if a is 0 in either of these equations, this entire part will be 0, because anything multiplied by 0 is 0, and then you would just be left with a constant, which is not a type of function that we're going to be talking about. We're not talking about constant functions. And then if b is 0, your x goes away, right? Because anything times 0 is 0, so your x would go away, and you wouldn't have a function anymore. You would just have the cosine or the sine of some constant number. So you have to remember that a and b cannot be 0 for this purpose. We're going to talk about amplitude first, and amplitude can be found by taking the absolute value of a. So graphically, what the amplitude is, and you might have talked about this in maybe your science class or your marine science classes, graphically the amplitude is half the height of a wave. So how do we find amplitude? Our first example, I'm just going to use the letter A, is just cosine of x. Well, the amplitude would be our A value, and since there's nothing written in front, we know there's an invisible 1 there, so the amplitude in this case is just 1. Another example is 1/2 cosine of x. You're just taking the a value or whatever you're multiplying cosine by, so the amplitude is 1/2. And then the last example I'm going to do is -3 times cosine of x. Remember, you're taking the absolute value of the a value. So the absolute value of -3 is 3. So our amplitude for this function is going to be 3. Pretty easy. Now we're going to talk about the period of a function. And how you find the period of a function is you take 2 pi and you divide it by the absolute value of b. Graphically, the period is the length of one full cycle of the wave. So let's find the period of a few of these functions. The period of sine of x, or cosine of x, doesn't matter, is 2 pi divided by the absolute value of b. And remember, b is the coefficient of x. So since there's nothing there, we know there's really an invisible 1. The absolute value of 1, that's the same as 2 pi. So sine has a period of 2 pi. Cosine happens to have the same period. Our next example is going to be -2 times the sine of x over 3. Okay, well we can really write this as -2 times the sine of 1/3 times x. Right, this can be changed. I want to make sure that we all recognize that that can be written as 1/3 times x. X over 3 is 1/3 times x. So that means that my period now, if I'm using this formula, is going to be 2 pi divided by the absolute value of 1/3. How do you divide a fraction by a fraction? Remember, you multiply by the reciprocal. So I'm just going to go up here for some extra space. I would have 2 pi over 1 times the reciprocal of 1/3, or the absolute value of 1/3, which is the same. So the reciprocal of 1/3 is 3 over 1. So that's going to give me 6 pi for my period. -2 times the sine of 1/3 x is 6 pi. And my last example is going to be 3 times the sine of -2 x. So now I'm going to write this. My period is going to be 2 pi over the absolute value of b. My b value is -2. Don't forget the absolute value. So I have 2 pi over 2, which is equal to pi. Still pretty easy, right? Frequency is easy as well. So frequency is actually just the opposite. Frequency is going to be the absolute value of b divided by 2 pi. And I just have one example for frequency because I think that you're starting to understand this. 4 times the sine of 2x divided by 3, which we all know that can be written as 4 times the sine of 2/3 times x. And frequency is the opposite of b, the absolute value of b divided by 2 pi. So the absolute value of 2/3 divided by 2 pi. Again, a fraction and a fraction, so I'm going to do 2/3 times the reciprocal here. This is really over 1, so 1 over 2 pi. My 2's cancel out, so I'm left with 1 over 3 pi for my frequency. So 4 times the sine of 2/3 x, the frequency of that is 1 over 3 pi. And that's it for this section. Told you it was going to be a short video.